Hello. Okay, in this video, we're going to do inverse trigonometry and trigonometry that involves angles that are more than 90 degrees. Okay, so first, if you recall from the previous videos, that the basic sine, cosine, and tangent can be explained with a right-angled triangle, correct? However, in this video, we're going to take a look at what sine inverse is, cosine inverse, and tangent inverse. Alright, so similarly, we're going to use the same right angled triangle that is going to be drawn on the screen. Of course, the longest will be hypotenuse and adjacent and the opposite. So okay, this is a right angle pattern of drawing. This is the angle we're talking about. So this is the hypotenuse, opposite, and the adjacent. Okay, so we know that, for example, if we let this be x, this angle be x, then we have sine x is equals to the length of the opposite divided by the hypotenuse, right? Okay, so for example, if I tell you that in the opposite is, let's say 1 cm, and the hypotenuse is 2 cm, then we know that sine x is equals to half, correct? So the question is, how do we find what x is? So in order to find what x is, all you need to do is to shift the sign to the other side. But you can't just shift it like that, alright? So what you need to do is actually do this, x is equals to sine inverse of half, which will give you, in degrees, if your calculator is in the degree mode, 30 degrees. Okay, so sine inverse is just kind of like you bring it over to the other side of the equation, alright? It's just to find the angle of something, alright? So normally, for example, in basic algebra, when you see something like, let's say I have a algebraic variable y, okay, where y can be any number, right? Can be 1, 2, is any real number, right? So if you see y to the power of minus 1, this is the same as 1 over y, correct? Yeah. So however, in trigonometry, when you see functions like sine, cosine, and tangent, sine inverse does not mean sine inverse of x is not equals to 1 over sine x. Okay, so sine inverse of x is not equals to 1 over sine x. Alright. Yeah. Okay, so back to inverse trigonometry, it's actually that straightforward. So similarly, if I say that cosine of x, right, is equals to the adjacent divided by the hypotenuse. So for example, let's say the adjacent is let's say 0.7 cm. Okay, so we know that the adjacent divided by the hypotenuse would be 0.7 divided by 2, okay, which is equals to, I think, 0.35, and we want to find, in this case, what x will be. So of course, in this scenario, we do not have O is equals to 1, because it might not be a proper right angled triangle. Okay, so now this example we just deal with cosine, alright? So in this situation where cosine x is 0.7 divided by 2, which is 0.35, we want to find what x is. So x is equals to, just bring the cosine over, bring it over to the other side. So cosine inverse of 0.35. And the answer will be 69.5 degrees. Okay, so that basically sums up what inverse trigonometry is. Okay, the last example we'll do will be tangent. So again, I'm going to erase this, and I'm going to write, for example, let's just take this as 1.3 cm. Okay, In this situation, we know that tangent of x is equals to opposite divided by adjacent, which is equals to 1.3 divided by 0.7. I'll just leave it like that. And x in this case will be, again, bring it over, so that's tangent inverse of 1.3 divided by 0.7. Okay, so you can see like when you bring the tangent over to the other equation, you have to inverse it. Alright, and you have to inverse the whole thing. Okay, you have to inverse the whole side of this side. So for example, you can imagine this thing going over and tangent inversing everything on the other side. Okay, so we have that x will be equals to let me just divide it in the calculator, 61.7 degrees. Okay, so that is basically inverse